So if you run the function x in parentheses cubed minus parentheses x minus 1 cubed, you will always elicit, or every time I've tried, which has been many, you elicit a prime number, or what I would term like a super prime, which is a prime number, a number that has only prime factors. That same function also holds true for square roots, like x squared minus x minus 1 in parentheses squared gives you the same thing, and they seem to go up progressively. The square one goes up more deliberately. It's like it's a slower. The quantity of the prime seems to go up. Then it's like a more steady one with the x squared. I don't know exactly the pattern, but there's just a difference. But they both elicit prime numbers. And even if you take then, it doesn't even have to be like x minus 1. It could be x minus y. So like x cubed or x squared. Well, I just rashed it in my head and it seemed to work. X squared minus x minus y squared. So it could be like, I did like 13 and 14, 13 and 4. So 13 is 169 minus 16, 153. So that turns out 17 and 9 squared. So again, like you get, that helps you with doing that function, picks out, and it's spatially, it's three-dimensional coordinates what it's working with. It gives you the prime number, but numbers have such physical basis. Like some function, some meiosis function or mitosis function does like a base 11 that's like 10 finger regions to allocate a certain protein reproduction for, but it has to also have it has to have a place in it where they're all coalesced in the brain. So it's like a function of 11, whereas you wouldn't. That's using a prime number. It's like a ratio function. But those prime number things, functions that you can call them or whatever. I call them a prime number generator, because if you did the number Google minus 1, that thing will break down into either one prime number or many prime numbers. But so then if you take a cube and from the center point of the top of this, a square, that square, put a cross in it, and then a cube made out of that square. So the center point of what is essentially 8 smaller cubes, you got the -4 quadrants, in the coordinates less than 0, and then the 4 above 0 in a cube to have x, y, and z. So you could, if the center point is 0, 0, 0, spatially, the cube hypotenuse, so not the square's hypotenuse, which is a function of square root 2, the cube one is a function, I think it's square root 3, it breaks down to. So it's everything is 1.71. It's almost, or 1.41. It's almost 1 divided by 7, almost, working with it functionally. But so then, if you circumvent with a sphere that cube, so that all 8 corners of that sphere are touching the sphere of the circle. If you know your field like that as a sphere, this thing will line like prime numbers using the formula x cubed minus x minus 1 cubed. That will line up all of the prime they will, like all of those coordinate points. If you shot a line up from point 0, 0, 0, coordinate 0, 0, 0, if you like shot a beam of light at the cube hypotenuse up or down, but negative might come out different, so I would say up. Try up. You're going to have like a perfect line hitting all prime numbers, because that would just come out of any corner. That's what the prime number always ends up being. It's a spatial thing. That's why the x squared minus x minus 1 squared. Like if you think about it, you're laying tile, like 3 times 3, you have 9 tiles. You have 9 of 3. That last tile you lay, if you just do it sequentially, like you don't make the tile, you don't put tiles like this corner and this right spot here. It's like if you do it linearly, go up or down, the last thing you lay is the prime number or the super prime, like 9. So number 9 on that 3 by 3 is that. It's specifying, that's how it specifies prime numbers, is laying it in a square pattern. It's like this the number will work, the function will work out because you like conceptually almost by its like visual proof. Like you'll do it. You could have things that are 9 square, units, but like not be a perfect square. Like that square footage you could put in like a rectangle, like 4.5 times 2. You still have the same square footage, but by doing it as according to like the squaring, but those, it's helping like to navigate over immense or vast